Hi everybody, this video is from page 14 of your new Unit 9 packet, and it's in preparation for Tuesday's lunch tutorials on derivative rules. So make sure that you have your resources available, you have your packet out in front of you, and you're ready to take notes. Also on page 13 of your packet are all of the derivative rules that I'll be using throughout this model problem and that we will be using in tutorials tomorrow. So it's a good idea to go over those and make sure that you're comfortable with those rules. So here we go. Part A of this model problem defines for us h of x equal to sine of f of x, and we're asked to write the equation of a tangent line to h at the point where x equals 1. So we have this function that's given to us, the equation of a tangent line, and an x-coordinate of x equals 1. So as you know, anytime that we're asked for the equation of a line tangent to a graph, we're going to start this process with the template here that we're going to try to populate and substitute in given values for. So I'm going to definitely need a point of tangency and a slope throughout this process. That's going to be my guiding force. When I can find those two things, I will be done with the problem. In part A, the point's x-coordinate is given to me. So I've got one piece of information that I'm starting this problem off with, and I just need to find the y value and then the slope. So from Algebra 1, if I have an x and I need a y, the easiest way to go about finding a y value for a given x value is to plug that x value into your equation. So what I'm going to attempt to do here is evaluate sine of f of 1, since that's the input that I've been given. Using my table, I can see that f of 1 is right here, 3 pi over 4. So this problem will have a y value equivalent to the sine of 3 pi over 4. With a little bit of unit circle recollection, we should all be able to land at a place where we reduce that down to square root of 2 over 2. That's the sine of 3 pi over 4. So I'm coming over here and replacing that y coordinate with root 2 over 2. Now what we've been spending a million years on, it seems, is this big connection that a slope is just a derivative. So the slope that I need in order to be successful with this problem is going to require that I find the derivative of our function. I need an h prime of x here. H of x is sine of f of x. So we know, a little side note, our trig derivatives with our little graphic organizer there. Sine is going to go to cosine of f of x, since that's the function inside of the original problem, multiplied by, the derivative of that inside function, f prime of x. Classic chain rule here that I'm using in order to take the derivative of this function. Since I was able to do that, the slope is a numerical value at our point of tangency. So I'm able to just take this derivative that we found and plug a 1 in. Cosine of f of 1, well, I already circled that on the table. F of 1 we decided was 3 pi over 4, so that's going into the cosine graph. And then f prime of 1, when I look for that, I see it right next to there, is square root of 2. Again, with some unit circle comprehension, I'm able to arrive at the value for cosine of 3 pi over 4 by thinking about the second quadrant of the unit circle. Cosine represents x, so in quadrant 2, I'm actually going to get a negative square root of 2 over 2 for my cosine of 3 pi over 4, multiplied by that root 2 over 2 that I grabbed from my table. Clean this up a little bit. My numerator is negative 2 when I multiply those radicals. Denominator is still a 2, so I get a final slope of negative 1, which means to fully answer this question, I just need to put all these pieces together in an equation of y equals negative 1 times x minus 1 plus the square root of 2 over 2. Tangent line has been written with my point of tangency and my slope. Now I'm ready to tackle part B, where I'm defining a new function, r of x equal to x squared times the square root of g of 2x, and we're asked to find r prime of x at x equals 2. So something that I said there that I don't know if you caught, but this is x squared times g of 2 of x. It's really important to realize that this is a product of two functions inside r of x here. And the way to handle a derivative of a product is with our product rule, which requires us to use fig plus gif. Just some notes at the top here. F is always the first function, so in this case that's x squared, and g is always the second function. For us, that's the square root of g of 2x. You can see right away the harder function is going to be that g function. It's going to be a pretty intense derivative that we're going to be looking at. But right away, I'm not intimidated at all by f because I know f prime is just 2x. If I can do some pre-work here and go ahead and establish g prime, I'll just be plugging in a minute and it won't be super scary. On those key levers on the front, or I'm sorry, on page 13, I see that the square root of x has a really nice derivative of 1 over 2 square roots of x. For us, I don't have a square root of x, I have a square root of g of 2x. But that's going to be 1 over 2 square roots of g of 2x then, anchoring my derivative here. And then I'll just need to multiply by the derivative of what's under that radical, my chain rule again. G prime of 2x, outside function, times 2. So that g prime is definitely a mess, but since I've got all that established, I'm going to come over here and try and start thinking through r prime of x using my fig plus gif. F prime I established is 2x times g, that's the square root of g of 2x, plus g prime, here's the really big, messy derivative of 1 over 2 square roots of g of 2x times g prime of 2x times 2 times f, which was just an x squared. Tried to color code, but you can see I just used fig plus gif here. And if I want to establish my answer now to the question, I need to plug a 2 in for every x. I'm going to do some mental math as I go so that I don't have to write all this down, so bear with me here. 2x, I'm going to replace the x with a 2, so that's 4. Square roots of g of 4 when I multiply the 2 by 2 here, plus 1 over 2 square roots of g of 4 times g prime of 4 times, let me see, 2 times 4, so I get an 8 at the end of this. And what I'm going to do now is utilize my table to try to keep simplifying. I get 4 square roots of g of 4. Here's g of 4 up top, that's 9. Plus 1 over 2 square roots of 9 again, because g of 4. Times g prime of 4, that's one column over, that's 3, times the 8 that I already had. A little bit more simplifying, 4 times the square root of 9 is 12. Plus, this is 1 over 6, if I do some math here, times 24. So 1 over 6 times 24. That to me looks like 12 plus 4 for a final answer of 16. All right, and the last problem here on our model problem is part C, where we have q of x equal to 2x over f of 3x, and the question's asking us if q is increasing, decreasing, or neither at x equals 1. Justify your answer. So some quick pre-work. If I want to decide if a function like q is increasing or decreasing, according to my stairs that we worked on earlier in the year, that's directly related to if q prime is positive or negative. So I read between the lines here. What this question is actually asking me to do is find the derivative at 1, determine its sign, and then draw a conclusion about the original function. So in this example, I see a quotient, and kind of similar to the last problem, we're going to be using this fig and GIF idea, but a quotient rule takes the difference of those things and divides by g squared. Just if that last piece was helpful in the last example, f is always the top function, g is always the bottom function, so in this case that's an f of 3x. And it might be wise if you want to just slow down and find your derivatives of every piece first and then go plug into your quotient rule. First one's not scary at all. 2x goes to 2. G is f of 3x. So again, a little chain rule. These are creeping up all over the place. I take the derivative of the outside, f prime, don't touch the inside, and then multiply by 3, because the derivative of 3x is 3. I've got all the parts ready to rock and roll, so I come down here and say q prime of x is f prime, which is 2, times g, f of 3x, minus g prime, f prime of 3x times 3, times f, 2x, all over g of x, f of 3x, squared. I'm going to plug in a 1, do some simplifying, and see if I can get to a conclusion. So again, doing some mental math here. This is going to be 2f of 3's minus f prime of 3 times 6 at the end, because 3 times 2 times 1 is 6, all over f of 3 squared. I'll use my table to get some values now. Looks like f of 3 is just 1, so that first term is 2 times 1, or 2. F prime of 3 is 5, and 5 times 6 is 30. And f of 3 again is 1, so 1 squared in the bottom is 1. It looks like I get an answer of negative 28, which is fabulous for one reason. It's less than 0. So I can draw a conclusion here that says q is going to have to be decreasing at x equals positive 1, because q prime of 1 is a value less than 0. So a lot of relationships being recapped here in this model problem, with the foundation being a review in your derivative skills. The rest of your pre-work is to handle a couple multiple choice questions on the following page, so make sure you attempt those, and we'll be scoring them when you arrive at tutorials tomorrow. See you then.